New pictures captured by the James Webb Space Telescope have stunned researchers. Instead of expanding our perception of the universe, these pictures revealed a disturbing reality: our current understanding is lacking in grasping the possibilities of the universe in its early stages, where the hypothesis of the Big Bang seems to reach its limits. This discovery drives us to contemplate new theories about the universe's beginnings. The question arises regarding how the universe was comprehensively shaped and why. This new discovery challenges even the most experienced researchers to learn more about the Big Bang and its complex details. To better understand, let's examine the concept of the Big Bang itself. Contrary to mainstream thinking, the Big Bang was not an explosion in pre-existing space. Rather, it was the creation of space itself, along with matter and time, approximately 13.8 billion years ago from a singularity. In physics and cosmology, a singularity describes points where gravity is so intense that the curvature of space-time becomes infinite. Today, after billions of years, we observe that our universe is part of a grand cycle of continuous expansion. However, the universe is not drifting into pre-existing space. Instead, space itself is expanding in size. According to current theories, the first stars began to shine between 200 to 300 million years after the Big Bang, marking the end of the so-called Dark Ages, when the first luminous celestial objects coalesced to form mature galaxies. But how quickly these galaxies formed remains a mystery. A wealth of data emerged through the first pictures obtained by the James Webb Space Telescope in July 2022. Experts reported that the telescope had detected various galaxies, some of which existed as early as 300 million years after the formation of the universe. However, in contrast to the vast structures formed later, these early galaxies were significantly smaller and less massive, aligning with the scientific model accepted by researchers. The density of matter in the early universe was simply not sufficient to give rise to galaxies the size of those observed today. What started as the detection of 6 glowing red-shifted spots from the James Webb Telescope triggered one of the most significant astronomical discoveries in recent times. Although these newly discovered galaxies are comparable in age to previously recorded ones, they are as massive as our Milky Way, creating an intriguing mystery. After analyzing a series of images captured by the near-infrared camera, experts identified the aforementioned light sources using redshift to determine that the light took more than 1 billion years to reach Earth. Consequently, the structures existed around 570 million years after the supposed Big Bang. Remarkably, these galaxies were so massive that they challenged standard cosmological assumptions. Instead of finding smaller galaxies, scientists identified structures nearly as large as our Milky Way. One of these galaxies, for instance, was already more than 10 billion times the mass of the Sun, potentially surpassing this mark. Whether this scenario is accepted or not, the mystery remains. Even in this case, there would be significantly more luminous mass in the early universe than previously expected, presenting a conundrum. These identified objects contradict almost all traditional cosmological theories. Regardless of whether just one of these galaxies is real, it would challenge our prior assumptions. The density of matter in the early universe would have had to be several times greater than previously believed to account for this phenomenon. Another strange explanation hinges on how these galaxies formed in a manner that remains obscure to us. These discoveries and discussions about the Big Bang have led many researchers to question this theory. Numerous astrophysicists with alternative viewpoints feel their perspectives are not adequately heard in scientific journals. Even those who express doubts about existing theories are often dismissed. Despite this, researchers advocating for the Big Bang theory continue to confront unanswered questions, such as how, 13.8 billion years ago, something could emerge from nothing. Could there have been some triggering event? Was it all a coincidence? Physicist Steven Weinberg pointed out that time, as we know it, began solely with the Big Bang, suggesting that this process could not have been triggered by something outside it. Another question concerns the uniformity of radiation and density across the universe. On a cosmic scale, we observe similar densities and distributions of galaxies, nebulae, and radiation everywhere. Conventional analysts explain this phenomenon through cosmic expansion, but other experts have developed a theory of turbulent expansion, suggesting that expansion ceased in specific regions but continues elsewhere. This raises the possibility that other universes may be forming with their own physical laws. What if the universe is not the entirety? What if another universe existed before our own? In this case, the Big Bang might be part of a larger cycle. Additionally, in 1955, an article appeared in NASA Space Times arguing that the universe may have always existed, challenging the idea of a Big Bang. In this view, the expansion of the universe would not exist, and the steady arrangement of matter could give the illusion of expansion. Another intriguing hypothesis, emerging from quantum physics and string theory, suggests that our universe may be a 3D projection onto a surface, implying the possibility that our reality is a higher simulation. This connects to the Kardashev scale, which measures a civilization's ability to harness energy. If a Type 3 civilization existed and could harness the power of an entire universe, it might have created an optimal simulation. These discoveries lead to profound mysteries and ongoing scientific inquiry. The new images captured by the James Webb Space Telescope have reignited discussions about the very fabric of our universe, testing established theories and provoking scientists to reconsider fundamental cosmological ideas. At the heart of this inquiry lies the theory of how things came to be, according to which, around 13.8 billion years ago, the universe emerged from an extraordinarily dense and hot state, expanding rapidly, resulting in space-time and matter as we understand them today. This cosmic event is not merely an explosion in pre-existing space, it may encompass the very origin of space itself. The concept of a singularity, where gravitational forces are so intense that space-time becomes infinite, supports our understanding of this primordial era. However, the discovery of early galaxies by the James Webb Telescope challenges our assumptions about how quickly structures formed in the universe's infancy. These galaxies, identified within a few 100 million years of the Big Bang, appear remarkably evolved and massive, contrary to current cosmological models. Significant questions raised by these discoveries pertain to the nature of cosmic expansion. According to the prevailing theory, expansion occurred within fractions of a second after the Big Bang, causing the universe to grow exponentially. This rapid expansion explains the uniformity of the cosmic microwave background radiation observed across the universe today. However, new discoveries suggest complexities in the early universe's development that may necessitate adjustments to inflationary models. The formation of galaxies like those seen by the Webb telescope prompts cosmologists to re-evaluate the conditions and processes governing the universe's early development. These galaxies, now significant in size and mass soon after the Big Bang, imply a density of matter that exceeds previous estimates. The mystery deepens when considering how such massive structures could form and evolve in a relatively short cosmic timeframe. Furthermore, the discovery of these early galaxies raises intriguing questions about the nature of dark matter and dark energy, two elusive components that constitute the majority of the universe's mass and energy content. While dark matter is believed to provide the gravitational scaffolding essential for galaxy formation, the distribution and properties of dark matter in the early universe remain uncertain. In line with these astrophysical mysteries, theoretical physicists are exploring alternative cosmological models that challenge the conventional Big Bang perspective. Some theories propose that our universe is merely one among many in a vast multiverse, each with its own unique physical laws and constants. These ideas, arising from advancements in string theory and quantum cosmology, suggest a more complex and interconnected universe than previously imagined.
New images captured by the James Webb Space Telescope
One idea gaining
have
traction is
surprised
eternal
researchers.
Inflation, wherein universes
Rather than
continually
broadening our
emerge from a
understanding
larger
of the
expanding
universe,
space.
these images
This
revealed a
hypothesis
disturbing
posits
fact.
that our universe could
Our
be
current
just one
physical
bubble among
understanding
countless
is not
others,
sufficient to
each
explain
with
the
its
nature
own
of the
distinct
cosmos in
properties.
its early stages.
The
where the
challenge
Big Bang
lies in
theory
finding
reaches its
observational
limit.
evidence to support such
However,
theoretical
how
notions as they
fast
push
these
the boundaries
galaxies
of
grew
empirical
is still an
verification.
unsolved enigma.
Another provocative
An important
hypothesis
clue to
is that our
solving this
universe
galactic
exists within
enigma
a simulated
emerged through
reality
the first images
akin to a
captured by the James
computer-generated
Webb
game.
Space Telescope in July
This idea draws
2022.
parallels to advancements in
Experts
artificial
announced that the
intelligence and
telescope had
computational
detected
science,
a number of
where
galaxies,
simulations can
some of
replicate
which had
complex
already
systems with
existed some
astonishing
300
fidelity.
million years after the formation
If true,
of the
our
universe.
perception of reality as a singular
However,
physical
compared
universe
to
could
the
be
galactic
fundamentally
structure in a
altered,
continuing cycle,
raising significant philosophical
as soon
and
as this
scientific
universe
questions about
ceases
the
to
nature of
exist,
existence.
a new one
Moreover,
emerges from it.
advancements in observational
According to
cosmology
this
continue to
perspective,
reveal the
our
universe's
universe
vastness
is
and
part of a
intricacy.
larger multidimensional structure.
Telescopes like the
Within
James
this
Webb
model,
Space Telescope,
the idea of an
with its
eternal
remarkable
cycle of collapse
sensitivity
and
and
rebirth of
resolution,
the universe
promise
is
to
put
unveil
forward.
even more secrets of the
However,
universe.
this is not the only
Future
perspective
observations may
presented in
shed
the
light
field
on
of
the earliest
cosmology.
moments of the universe,
Apart
providing
from the Big Bang
insights into
theory,
its ultimate
in
fate
1955,
and the underlying rules
for
that
example,
govern its evolution.
an article appeared in NASA's
Beyond
Cosmic
observational
Times arguing that
cosmology,
there may have never been
particle
a Big Bang
physicists are
since the
investigating
universe
the
has
fundamental
existed for an
particles
infinite
and forces
time.
that shape the universe.
In this view, the expansion
mission
of
to
the
unify
cosmos would
gravity
be
with the other three
non-existent,
fundamental
and the
forces,
continuous formation of
electromagnetism,
matter
strong
could give the
nuclear
impression
force,
of a
and weak
constant
nuclear
expansion
force
of the
remains a
universe.
central goal of theoretical
Another
physics.
intriguing though controversial
Concepts
theory
like quantum
comes from the
gravity and string
realization
theory
capable
offer
of fully
potential
harnessing the
frameworks for
power of an
understanding
entire
these
galaxy.
fundamental interactions
It could have
at
created
both
a perfect
the smallest
simulation.
and largest scales of the universe.
However, finding out the
in the
truth
realm of
in
quantum
such a
mechanics,
scenario is
the
a very
concept of time
complicated
itself
matter.
remains a topic of intense
Do you
debate.
still believe in the Big